Yeah, hi. So integrated reasoning, which I believe is a confluence of the two sections as such, the quant and the verbal, and it goes a little bit beyond as well, right? So how it is a confluence and what is that beyond factor? That is the core purpose of doing an IR class today. So let's start by first understanding what is IR and why IR in the first place. IR was introduced by GMAC 5-6 years ago in 2012 to replace one of the writing sections. Previously, there used to be two writing tasks of 30 minutes each. One of them was done away with, and the IR was introduced. The idea was that the new age information management issues and problems faced by the managers, the IR section represented that portion, that part of the testing skill set. So it essentially tests cognitive skills, and that was the main focus. Different colleges perceive IR score with varying importance. Now, what do I mean by that is your main GMAT score as such, scored out of 200 to 800, is a separate story. Your AWS score, scaled score of 1 to 6, is a separate story. Your IR score scaled on a scale from 1 to 8 is a separate story. So all three constitute your overall GMAT sort of result. And IR sort of becomes critical where people are applying for consulting and finance profiles, where you need to be more data oriented person, you need to be more analytical, you need to figure out information from long passages, from multiple data sets, cross referencing, and so on and so forth. So it's scored on a scale from 1 to 8. A score of 5 is a bare minimum benchmark, and 6 is a good enough score. So what's the format? You get 30 minutes to do 12 questions. And this is the only section where an on-screen calculator is also available. All right. Nevertheless, it's always advisable not to go through that, because 2.5 minutes per question, you don't have that liberty to type in and do. It's best to use your quick calculation skills, ratio proportions, percentages, all those concepts you have already seen. Based on that, it's always advisable to not go to the calculator. Only in a very case where you really think you need that, it's fine. Right, different problems and different answering formats. We will see what are the different problems and different answering formats. So essentially, there are 4 problem types, and each has a different sort of way of representation of the problem. The answering formats, the answers are not always in they are not always in your ABCDE format. In fact, almost I think half the problems don't have such a format of the answers. We will see through the tool today in what format the problem comes up. Linear instead of adaptive. So this is something that becomes, you can understand what the GMAC is trying to do. It is trying to give you all the problem sets, the same problem sets, so that you are tested on the similar problem types. Nevertheless, just like other QA and BA sections, you must answer a problem and you cannot go back. So the problems will be placed in any random order, in relative order of their difficulty. So you don't, in any case, however, you cannot, strategize to leave a problem and go back. So that's not the case, just like the other sections. So subparts to each problem. Now, what is that? That is something very crucial again. All these things will become clear as we do some practice today. Subparts to each problem. Essentially, there are 12 problems. even those 12 problems have subparts, and there is no partial marking. So these subparts are not in the format of part A, a separate answer with different options, and then part B with separate options. These would maybe constitute a problem in the sense that some yes no sort of reply you have to give to some statements. So they are on some broad concept. You will see them clubbed together all together. So those parts will not be separately placed. They will be placed all together in one column maybe, or maybe there will be a passage with a drop down menu and you will have to choose. So in that fashion, it's a one holistic problem. So you need to get all of them right all together to get it correct. So let's say there are three statements with yes, no, and the correct answer is yes, no, yes. You need to get yes, no, yes in order to get your answer, get your score. But otherwise, you are not given any partial scores. So no concept of partial marking in terms of the subparts of the problem. So that's the broad idea. Scaled score in the range 1 to 8, single point increments. So essentially, you only get a single point value. 1, 2, 3, 4, 5, 6, 7, 8. As I just mentioned, 5 is a bare minimum benchmark you should get. 6, 7, 8 are good scores. 6 is so this percentile over here that I have mentioned. It's based on the last 4 to 5 year data. Of over the last 4 to 5 years, 4.34 has been the mean that has been evaluated. And 6 is a 67 percentile, 7 is an 82 percentile, 8 is a 93 percentile. Okay, so 4 types of IR. There are tables, there are graphs, there is something called as a two-part analysis, and there is a multi-source reasoning. Now, two-part analysis and multi-source reasoning might come as new terms to most of us if we have not yet started practicing. Today we will take a look at tables and graphs, and tomorrow we will do the two-part and multi-source, so that we can just get warmed up to the basic problems on tables and graphs, and we'll then look at the two parts and multi-source reasoning tomorrow. Essentially, we will only after looking at the problem types, we will come to understand the things I have been talking about. What is the differentiation between these 4 types? So these are the skill sets tested over here in the problem types. You start by basically recognizing the basic thing. You see of information, you recognize it, and you reply. Then you start applying. And then you start evaluating, strategizing, and infer. So all of these terms represent the sort of skill set being tested in IR. So just to summarize the thoughts, that the problem types will definitely constitute some basic knowledge of QA in terms of ratio, proportion, percentage, your mean, statistics, and maybe even a little bit on probability and set theory. So these topics you may or may not have done as of yet. However, in the problems that we'll see, it will not be very in depth. So when I talk of probability, it will not talk about what are independent events. It will at a very basic level ask you problem on, okay, for what's the probability of this. Sometimes that probability will translate to as simple as an idea as a percentage, right? So conceptually, it will not be very deep, but the toughness of IR comes from having so much information in front of you and knowing where to go to find the correct answer. Because there will be a lot of information written in long sort of passages. Some formulas might be given for you to work upon, and then some numbers will be written somewhere, and then you'll have to mix, just make the whole sense out of it, and then analyze some yes and no idea. So that is what makes IR difficult. It does not get difficult in terms of just pure number calculation skills. It gets difficult when you start mixing all the concepts of quant, verbal, and maybe even beyond. That what makes IR, right? However, today we will try to keep it a little light in terms of we'll do tables and graphs, which will mostly be quant oriented, because as we know, tables, graphs, definitely something to do with numbers. So today the session will be oriented towards these, and tomorrow will be a more on direct practice sort of a session, and we will see what is the two part and multi-source. This is a sort of a new thing for most of us that we'll see tomorrow. So now I will move on to the problems themselves. Let's start getting interactive, and I would love to get your responses either on chat, or you can even speak out. I will start a problem, and anybody can share their responses. So just give me a minute to set up the whole. Yeah, okay, Abhay. Just give me a minute. Anybody not having a record can message me. I will give the same. Fine. Just give me a minute. I'll start up the screen of the problems. Yeah. So everybody can see this page, right? For each of the 11 employees of a small company, this problem, right? So just take a minute and please go through, and we will start analyzing. It's a medium level graphics problem. Yeah, hi. I'm using to see the option to record. Okay. Yeah, anybody wants to give some input? Let's keep this session interactive, by the way, because the idea today is not a one-way monologue. I would really want everybody to start analyzing the problem, giving me some inputs, because only then it would be beneficial to learn together. Yeah, you can just type here. So you can just respond to me, Pranita, on the chat window, because obviously this screen I am managing. Fine. Would really love somebody to speak up either on chat. Uh, okay, Pranita is saying, okay, I am sorry. Let me just, I forgot to show you the options. See, this is a graphics problem. As I was mentioning in the beginning, uh, this in the graphics problem, you will have a graph on the left. In all the problems, you will have some information on the left, and on the right the problems, statement and options, whatever that may be. Over here in graphics you will always have a drop down way to select the answer. So all the options are less than, equal to, greater than. So based on that, so as I was just mentioning how it is a, so this is one whole problem. You need to select for both of them. Even see, even if I select for this and if I leave this blank, over here it is not allowing me to submit. So everybody can see what's the idea, right? You need to answer the problem. This whole constitutes one problem, and it has two parts when you need to select from two drop down menus. Yet to hear from anyone as such on the problem analysis. Okay, Jesh Kiran, less than, greater than, fine. Abhay is saying median JS is equal to less than median salary. Okay, fine. Abhay, do you want to explain to everyone?
Yes, hi, good evening. So, if you look at the graph,
Yeah,
what I could see was when we are seeing the job satisfaction rating, we have to see via the x-axis.
right,
So,
sure.
yeah, and since there are 11 entries, the sixth one will be the median entry.
Okay, so how do you do that?
So
How
you
do you find?
see the first one is at 30, the
Okay,
second and the third one are at 40.
yeah, tied up over there. Yes.
Yeah, the fourth one is at 45, the fifth one is at 50, and finally the sixth one is at 55.
Yeah,
So for the sixth one, his job satisfaction rating is 55, but
yeah,
his salary is 40% of the median salary.
yeah, yeah. So on the vertical line, we see that, right? Salary as percentage, and that is a little over 40, maybe 43, something like that. So it is
Yes,
definitely less than. Yeah. For the
right.
second part, let's move on. The employee having, okay, the median salary. How do I go about that?
Now here we start looking at the y-axis.
Yeah,
So the lowest value is the one that we just saw around 42.
yeah.
Then the second one is closer to 60. The third one is around 70.
Wait. I'll just interrupt you. So there
Yeah.
is the catch. I saw most of the people going by that logic of going the median. See, the thing is that it's saying the employee having the median salary. It's a very direct information. I do not have to find the median of the
Ah, okay,
people's
so it's
ranking,
100.
right? It's directly the 100% value.
Right. So yeah,
See,
that is the again.
mathematically, it so does happen that if you actually go along the y-axis and find the sixth guy, that actually is the 100% guy only. But
101.
in case the problem setter wanted to make it difficult, he would have not made the sixth guy on the 100%. So a good
Mm,
catch, although your
right.
answer is correct, but
Yes.
you understand what's happening over here, right?
Absolutely. Yeah.
Yeah, great. So a great learning, how very at a very basic level, what makes the problems difficult is precise understanding, which we have
Hmm.
always seen so far. Thanks, Abhay.
Right.
So yeah, so essentially what is happening over here is the employee having the median salary is the guy sitting at the 100% value, and we are asked what's his job satisfaction rating with respect to the median rating. Now the median rating we just saw in the previous part is 55. This person with a 42% on the y-axis. So this person has 55 and this 100% person has 60. So it's greater than. Okay, great learning over here. Let's move on. Yeah. So, tables. Let me just clear or mention some things. Tables is a very straightforward data problem. You will obviously have a table. What's critical or what's important for you to know is that you see these six columns. You can, if you click on any given column at the top over here, it gets sorted out. So over here, hourly output I arranged. So you can see everything gets arranged according to hourly output, and so on and so forth. So for any analysis, if the problem somehow asks you to maybe see the top three and make some analysis, this helps out. So based on that, let's read out the problem and try to see. Fine. Maybe I'll need to sort out so that you can answer the problem. The first problem says among the industries in the table, the freight structure industries were the only industries to experience. Okay, so which are the freight industries? Essentially, freight industries would mean wherever I can see something of freight, right? Which would be freight trucking local and freight trucking long distance. So it's asking that I'll need to analyze whether or not these are the only industries to experience positive average change in every category. So there are essentially five categories over here. If I see these two rows, so I'll need to see along the rows for freight trucking, I see 3.1, 4.0, 0.8, 4.3, 0.4. Everybody with me on that? And similarly over here for the trucking, it's 1.3, 2.8. Now, definitely all of them are positive. I also need to just confirm that these are the only ones to have positive. So if I see very quickly, line haul, one of them minus 1.9, postal service minus 0.2, and so on and so forth. I can very quickly verify couriers minus 0.2, minus 0.3, minus 1.6. So everybody with me on this that yes, for all the other rows, I do have at least one number as negative. So it's a yes. So everybody with me on that, right? Let's move on to, so again, you're seeing the format which I was trying to describe. You have three problems, three statements, and you need to verify that using the data given to you. Uh, Based on the statements, you need to arrive at a yes or no. So it's one problem, three parts. You need to get all of them right. That's the catch. Right, moving on. The three industries experiencing the greatest average. Okay, anybody just wants to maybe just even type in what are they getting on this one? The second statement. If you want me to sort for any given column, you can ask me. Hourly output. Okay, fine. So yeah. Yeah, Jayaskiran is saying no. Yeah, so the reason is that the W, so it's asking that the top three should be transportation, which is capital T in the industry sector. I sorted out and at the top I saw 5.0 relates to W, warehousing. So it's a no because the highest, the three industries experience the greatest average annual percentage increase in hourly output. that highest value is a warehousing industry. So no. Similarly, let's see for the last one. Every industry in the warehousing sector, average annual increase for labor costs. Okay, Pranita, is that already? Pranita is asking, is that already the average, the hourly output column? Okay, let me just go to the problem once more. The three industries experience the greatest average annual percentage increase in hourly output. So, yeah, so this in lines, the this small paragraph at the top, if you read, it is mentioning the table shows average annual percent changes. So yes, this first line itself clarifies that. So for such doubts in your mind, just go back to the para written over there so that it's clear. So again, you are doing synthesis of information, not just from the numbers but also the information as such. This is a medium problem with a very small para over here. In a tough problem, there will be lots of information in terms of passages as well. This is just a very short 2-3 lines. Yeah, for every industry in the warehousing average. Okay, so let me see what are the warehousing. There are three of them, and it's saying average annual percent increase for labor costs. So I need to see the labor costs were greater than for any industry. So essentially it's saying that the labor cost percentage changes, are they the highest? So I found that couriers, general warehousing, and refrigerated. These are the three warehousing. And what are the labor costs? 4.8, 6.7, 4.8. Do I see any other higher value in this column? That's what I need to see. 4.8, 6.7, 4.8. No, I don't see anything greater than 4.8 in the column, right? So it's a yes, right? Everybody with me on this? Let's move on. Yeah. Okay. So I've chosen a sort of a hard problem on the tables. Uh, if you want me to sort any of the columns, you can ask. I think for the first problem, let me sort as per device X1. Essentially, all three problems just state a device name. So I would like to see if anybody can come with the analysis of the problem. Yeah.
Sir, in this case, X1 isn't dominant, right? Like ratings dominant, because as we can see, there is no other device that has as many zeros as X1 does.
So you're saying it is dominant or not?
No, I think the first one is no.
Okay. The reason is that you see a lot of zeros.
Yeah, and like I don't see it as many zeros in those categories.
Yeah. In fact, the idea is if the device needs to be dominant, then it essentially needs to be exceeding every other device in all the 8 categories. That is the whole idea. In fact, so by going by that idea, there should only be one, you know, dominant
But
thing.
sir, in this question, they say it's if it's to select yes if it's dominant over any of the other devices. So even if it is dominant over one of the other devices, I
Yeah,
think mark yes.
yeah. So as of now, device X1 is a no, because it has so many zeros, so it cannot be dominant over the others. So let's move on to XS. Good, Pranita. Uh, so yeah, let's move on to XS.
This one is a yes because
Okay,
it's dominant over X2 clearly.
okay, it's dominant over X2. Yeah, great. Good observation again. Yes. So we can see excess with x2 0 greater. So essentially, it says greater or equal to matches. Even if it matches or exceeds, it is dominant. So in several cases, it's matching 0 versus 0. We also have 2 versus 2, 3 versus 3, but there is nowhere where it is lesser. So yeah, it is dominant. Excess
But
is
it does not
dominant.
dominate for feature A. I'm sorry to interrupt. So if you see feature A for X1 and XS, it's less.
X X1. No, we are talking about X2. We are comparing XS with X2. I and what are you
But
comparing?
we have to compare over any of the other devices, right?
Uh, no. So come again. What are you saying?
It says select yes if the device rate is ratings dominant over any of the other devices in the table. So if you compare XS and X1, it's not dominant.
Okay. Okay. So again, this is a very minute thing. I think Pranita got it, but sorry. What's your name?
Jen.
Yeah. Hi, Jay. Essentially, we read very carefully. We need to just be sure that it is dominant over any one of the devices. If you read this statement, a device is said to be rating dominance over another device. For each of the following, select yes if the device is ratings dominant over any of the other, which means that at least one. Over any means does not mean it needs to be dominant over all of the others.
Okay.
Yeah,
Understood.
it's over any of the other would imply any one of the other devices. Essentially, one word, if it was written over there, maybe it would have been more clear. But if it's a hard problem, so he has made the language hard for you.
All right. Yeah. Thanks.
Yeah, Jay. Okay. So good that you clarified that. We are learning how the problems become difficult. Uh, Great. Uh, Moving on to this XZ. Let's see again.
It's not dominant according to me.
Yeah, very quickly we need to see XZ versus all the other 4 columns. It has a 0 to begin with on the top. So many zeros. So yeah, if we just very quickly look, we see obviously all of the 4 other devices for some of the features are dominant over XZ. So yeah, that's a no. So good problem. Again, we know good observations and some clarifications in language. We learned what is the difficulty that GMAC is testing us on. Yeah, this is sort of an easy problem. Let's do it nevertheless. So as per me, it should be less than a 2 minutes problem by all benchmarks, I would say. Just read through the problem, see at what is given, and very quickly you should be able to make out. Of the concerns that were rated highly important by at least one of the four groups. Let me show you what are the options. The first one has some numbers 2, 3, 4, and this drop down has the four groups.
Could you keep the second drop down active?
Yeah, those are the four groups. Biofuel at the top.
Okay.
Yeah.
Thanks. Is the first one 2 by any chance?
Yeah, it is 2. It is 2. Because the idea is that we need to see which sub part. So these are the sort of ideas which are shared by the four groups of the biofuels sector. So something called as availability of biofuels can be seen for the second and the fourth group, fuel distributor and end user. And again, the green image can be seen for the third and the fourth group. So yeah, I don't see any other repetition. That was the idea. Each of these concerns were rated as highly important by, we just discussed second and fourth, third and fourth. So the fourth person is common. So that's why the fourth person end user group, that is, it is rating them as highly important. Each of them, the concerns is rated highly important by this group. Fine, let's move on. Okay, yeah, sort of a good, nice little problem over here. Line graphs, and this is something I would like to highlight, that you need to be good at reading from the graph, right? What do I mean by that? I hope you will understand what I mean by that. Is that you have a graph in front of you, and you need to very on a very crude level, not you need to not be precise to the second decimal place, but on a very crude level you need to identify what's that number. So if I say, if you can just see, let's say, can you see blue dot at the seventh mark for the light blue line with a triangle? What would you call that value?
Around 22.
Exactly. Great. Yeah. So we see that it's a jump from 20 to 30, and it's a sort of a fraction, less than half, even less than 1/4, I would say. So yes, exactly. So that sort of reading is you should be very quick and good at that. So that because they won't be giving you numbers, they will be giving this graph. So let's see the problem and let's try to do that. I'll also just show you the options, graphics interpretation. So the first one has the 3 years for which the data is given, and the probability is given in obviously some decimal. Right. So anybody down with the analysis or anything, any inputs?
So do we look at the if we can look at the years 1993, then we see that there's a spike during those 7-day stays and 14-day stays, like or. So if we had to add them up, we'd have to compare during those spikes. So
Yes.
considering that, I find that in 1993, there is a huge spike for 14-day visits. So I feel like the probability would incline towards that. So 1993 would be my bet, but it
Okay,
and
okay.
that's very
Yeah, sure. See, over here, the difference is quite stark, you know. So 1993 is the answer. If you, but just to be on the safer side, it would be good to very quickly, you know, do the calculation. See, the answer is indeed this. So let me very quickly do that. For the black line, 93, you know, it's at 7 for the 7-day mark. It is around 12 or maybe 13, right? You can see that for the black line at the 7-day mark, and it's 50 exactly at the 14 days. So the sum is 0.62 something. So that is the highest one. If you similarly do the summation for the other two lines, for example, for the this 98 line, it's around 15 at 7 and around 25 at 14. So the sum is 0.4. And similarly, if you do the sum for the other line, it would be again be not more than 0.6 in any scenario. So yes, this is the answer.
how that probability was calculated. Is it?
Yeah. So, you know, again, as I was mentioning at the very beginning, probability when you see in terms of, see, how do I analyze these graphs? These graphs are nothing but, if you make sense out of it, any one of the three lines, if you sum up their values along the horizontal axis at their various vertical values, they should be 100. Otherwise, there is no sense to them, right?
Yeah.
It's sort of a probability distribution at a very, very basic level. So essentially, what it says is that there is 50% of the people in 1993 stayed for 14 days. That's the whole idea. So the probability is nothing but the percentage in only.
So I just add the percentages up.
Yes, exactly.
There is
So
no expected value situation here.
exactly, it's not asking you a grilling problem on probability concepts. It's just it just wants you to know that probability, when referred to in common language, if I distribute the data across multiple, over here the year is the uh, variable along which the stay is distributed.
Okay.
So those percentages are given to you, and that constitutes the probability in a sense.
All right. Thank you.
Yeah. Okay, so again, you know, great that we saw how this sort of a mathematical language understanding also is a sort of a key in the problems. So these are still some of the not very, very high level. This is still a medium level problem. We will tomorrow be going towards more grilling problems. Yeah. Although it's an easy problem, but a good practice nevertheless. Let's try this one as well. So I'm showing the options: low, moderate, moderate, high, and high for the first one. And the four options are just the same thing at the top written on the graph. So you can understand, even though it's an easy problem, the language has become a little bit more verbose. Right. I hope you know. Yeah. I hope somebody should just maybe give me some hints. Let's say I'm lost on my problem. Please help me out.
In the first drop down, we don't have the option for low, right? Low.
Okay. Okay.
So I'm eliminating the the points above 0.6, whatever percentage is there. It's highest when it is at 1. So I'm not considering that. In that case, I would select the black line with the triangles, and highest probability of changing my vote is during like on or near election day.
Yeah, great. Yeah, exactly. So you essentially what you did was you saw that there were two highest ones.
Yeah.
Both of them are almost at the same level.
Yeah.
So that creates a confusion. We tend to see we want to know what is the minute difference,
Mhm.
and there is nothing as such to read from the graph, and they are very very close. But as you rightly said, that the first line, which is actually going downwards in that sense, with a blue dots on it, it is highest, but it is highest at a exposure of
Low.
low. So, but low is not here. So we
Yeah.
can only match up the black line, and the black line I can match up as it is high level of exposure, right? Is that correct? Because it is
Yeah.
4,
Yeah.
and so the black line is on or near election day.
Yeah.
Yeah, yeah, yeah. Sure. So how we observe these things. We are. It's again a good practice. Tables easy. Yeah, I think we should do this. It's problem more on statistics. We would maybe go through some concepts. I think some pretty good concepts we have learned on uh, statistics. For some of us, if we have not yet studied statistics as such, standard deviation might come as something new, or we might not recall that from our memory very quickly. So that's why I would like to discuss this problem. Uh, Let me know when you're ready to discuss. would you like, if you want me to sort as per any of the three ones?
So I think for this one, when we're talking about the standard deviation, it's basically the square of the difference from the mean.
Exactly, exactly.
Yes. So farther away it is from the mean, the higher will be the standard deviation.
Yes,
So from the table, we can see that sour has the highest standard deviation. So if we remove sour, then the standard deviation would decrease the highest. So that
absolutely,
answers the first two questions. The first becomes
absolutely,
true and the second becomes false.
absolutely, absolutely. Great, great,
And
bingo. So yeah, I think he covered it precisely that the difference, the square difference, if it is the highest and I'm removing that term, then obviously that would decrease the standard deviation the most. Sort of, I can also say averages. If there is a number of terms given to me and I'm removing the highest one of them, the average would decrease the most, right? So essentially, on a very basic level, standard deviation to calculate it is I take the average of the square difference from the mean. So it's at a very basic level. I'm doing the average of the square deviation, and if I'm removing the highest, numerically highest term, that will decrease the most. Yeah, absolutely. The third problem, the third statement, if Fournier and Sawyer were both disqualified and no other changes were made, standard deviation would decrease. Okay, so let's analyze how I can prove this thing. Fournier, okay, so Fournier is this person and his main deviation is 1681 and Sawyer is already the highest. So how do I confirm that standard deviation would decrease?
so I think again, since it's the square of the difference from the mean, so
Yeah,
if the difference from the mean is decreasing, so automatically the square will also decrease.
yeah.
So in this case, if the value, if we remove both of them, then the mean will move in the upper direction. If it moves in the upper direction, then we need to calculate basically what is the difference of the mean from the for the remaining values.
Okay, so not very precise. I appreciate the effort. See, the idea is, as I was just saying, on the averages, just make it very simple for yourself. Forget about the square root. See, uh, taking the square root will not change anything. At its very basic, we are taking the average of the deviations from the mean. So over here we have 10 values. Now, for averages, if I am removing terms which are more than the mean, if I'm removing those terms from a data set, then the average would decrease. Very obviously, that makes sense, right? So over here, what we need to do is, see, I'll just sort it out very quickly. Just sum these values, the square differences, very crudely in terms of thousands. Like the first one is almost 3500, the second one is almost 3000. Let's very quickly sum them up. 6.5, then almost 2, 8.5, almost 1.7, 9.7, 8.3, then almost 10.3, almost 10.8. I'm almost at 11 maybe at best. So the average is 11,000 very crudely. I may be off here and there a little bit, but the average is about 1100 or so. So all those, both the values, the Fourier was at 1681, so it was definitely more than the mean. So that's the way to do this analysis. That how do you confirm that it is going to decrease the standard deviation is that because at its very core, the standard deviation is average of the deviations. I did the average on a very crude level, uh, you know. So again, you have this calculator, by the way, sitting down over here. But I would really advise, don't go to this guy. It's only going to kill your time. So That's the golden rule. Be very quick with numbers. If you have a table and graph problems, just do your basic intuitive quick uh, calculation skills. Those would always help you out. Let's maybe take a last problem for the day. Okay, this is a quite a simple one on very basic triangle similarity problems. I'm sure you have learned it a lot. I'll maybe take a good problem for the day. Mm, okay, do I want to do this? Uh, Wait, let me see if I can see some even better problem. Yeah, I want to end the day with this problem. Yeah. So what do we have over here? Can we so what do we need to look at? Uh, there are 5 dishes a restaurant has asked a focus group, and yeah.
In the first one, it's tofu, I believe, because it's the only one in the intersection of which doesn't change at all.
Okay, so how do I see? Like if I see like the last column, tofu against beef, tofu against chicken, tofu against fish, tofu against pork.
Yeah.
Every time I see tofu winning, sort of. So it's essentially what's the like? How do I analyze this table just to begin with for
So I look at like there are dishes mentioned on top and on the same dishes mentioned on top and on the right. And when I see like the cell that's the intersection of those two, it shows which one I prefer of those two.
right,
So,
right,
for example, in the column chicken and then there's the row beef, I prefer chicken over beef when those two are compared. But say between fish and chicken, I again prefer chicken stuff.
yeah.
And fish and
Okay,
beef.
okay. Okay, so this is sort of a triangular table. Why do we have that? Because the relation of A to B is the same as B to A, and in such a relations, we always get such a triangular table.
Yeah.
So something. It also reminds me of I have seen tables where distances are mentioned. Maybe we have 5 or 6 cities, and what's the distance between all of them taking two at a time? So you always get such a table when you have a correlation sort of a matrix where the A to B and B to A relationship is the same. Over here, it is the preference. It can be the distance between cities. It can be the probability when I'm throwing two dice. What's the probability of getting 1 and 5 on the other? So those things, when they are the same, such we get such a triangular table. That's how we analyze this. Whenever you come across such a table, just understand what's happening. It's a relation between two things which are the relation between them. The mutual relationship is same. So just I'm throwing some ideas. So yeah.
First one's tofu. Second one is pork.
Pork.
Okay.
So
Yes.
is it so one more thing can we do? Is it like if we see the figure like this, can we just calculate like which one is the maximum? Like tofu I found as maximum and pork I don't see. So it means tofu will have the maximum number and pork will have the less number. Like simply if we can.
Yeah,
Is
that's a
is
good
it
way
the
to look at it. It's a good way to look at it. But just to be on the safer side, make sure that all the relationships are holding true.
okay?
What I'm trying to say is that it's a good way, it's a good analysis, good point over there. Indeed, we don't see pork anywhere in this, table as such, apart from the two columns and rows at the top. So that's
Okay.
a good observation. Yeah. Uh, In fact, I think you are correct. If it's happening at the maximum times, see, if it's the maximum, it might be the one everybody's preferring, and still the maximum might not be the one everybody's preferring. So just to be on the safer side, do see that whether or not it is actually beating every other dish or not.
Okay, sure.
Yeah, yeah. Fine, great. We did some problems. I think we had a good session. We did discern some, very fine statements, language, how it plays the role. Uh, we'll continue the same tomorrow with the two-part and multi-source. We'll see those problem types, and we'll continue tomorrow. Thanks, all. See you tomorrow.
Sir,
Yeah, yeah.
just to confirm, pork dish was not compared to tofu, right? In this diagram,
Pork was not compared to tofu.
or I'm missing something?
Pork is see the pork on the row, on the row side, see pork, and it's compared with tofu in the last column. So if you are missing something, or when you're seeing this ways, go to the other side and see the other dish. So you're saying you're not seeing pork
Okay, okay, okay.
versus,
Yeah,
you
yeah,
got
got
the
it, got it.
idea.
On the
Yeah,
right side, pork is mentioned.
so that's why it's a triangular matrix. You won't find, if you are missing it along one side, go to the other side. That's the whole thing. As I just explained, the relation between A to B and B to A is same. See, essentially, if I'm going to complete this table, it will become a mirror image along the diagonal. Do you get the idea?
Yes,
Yeah.
that's
So that's why, that thing is not even written, because it's going to be a reflection of the same information, and they won't want to repeat the information.
yeah.
Yeah. Okay. Okay. Great. Great. Great observations. Thanks so much for all the participation. Great session today. We will do the same tomorrow on the other two problem types. Yeah. Okay then. Yeah. See you tomorrow.